Welcome to qnawire.
In this question, we are asked to consider the situation when a vehicle that is rounding a curve of radius r, and then it's possible that it may roll over. Okay, so we'll be considering a SUV. Okay, and then you have two tires. Okay, this is view from the back. Okay, so we assume that it's turning to the left, so the centripetal force is pointing to the left. Okay, so the two tires, the distance between the two tires is W. Okay, the distance of the center of mass from the ground is H. This is the inner tire, and then this is the outer tire. Okay, on the when it is at a critical rollover speed, okay, the inner tire will be raised up, and so there are only two forces acting on the outer tire. Okay, so the two forces are the frictional force and the normal force. Of course, there's a weight, but this weight will come later. Okay, and then this is the cm. Okay, so in part A, we want to show that the critical rollover speed is given to given by the expression. Okay, so in part A, we are asked to consider the torque about the axis through the center of mass of the SUV. Okay, so and then we are going to say the torque that is pointing out of the page to be positive. Okay, and then we consider the torque about an axis through the center, through the cm of the SUV. Okay, so this means that we will be the net torque about the center of mass will be Fn times W over 2 minus F friction times H. Okay, and then from the free body diagram, Fn would be mg. Okay, and then the frictional force is the centripetal force, would be mv squared over r. Okay, and then at critical speed, Vc, we have net torque equals to 0. So mg W over 2 is equal to mv squared over r times h. Cancel the m. You rearrange the equation, you have Vc equals to Rg times W over 2h square root. Okay, shown. Okay, then in part B, we are given two vehicles. One is a passenger car with SSF 1.40 and SUV of SSF 1.05. Okay, so the SSF is the static stability factor. Okay, so this is equal to W over 2H. So our VC is equal to RG SSF square root. And then we can rewrite the whole thing to become like this. And so R is inversely proportional to SSF. Okay. Okay, so we have 1 to be the passenger car, okay, and then 2 will be the SUV. So R1 divided by R2, you want to find the ratio of the radii, okay. So this would be SSF2 divided by SSF1. Because the rest are constants, VC is constant, G is constant, so the ratio of the radii only depends on SSF, the ratio of SSF. So SSF2 is 1.05, SSF1 is 1.40. Calculate this, you get 0.750. Okay, and so this is the answer for part B, and that's all for this question.